Chapter 2 is going to focus on the normal distribution. And we're going to look at increasingly complicated, increasingly realistic scenarios. And the first scenario that we're going to be interested is in the situation where we're talking about the characteristics of individuals from normal populations in which the population mean and the population variance are both known. And then in the second scenario, more realistic, we're no longer thinking about individuals. We're interested in drawing inferences about population means, mu. So if we're interested in drawing inferences about populations mean mu, then obviously mu is going to be unknown. But in our first iteration, we're going to assume that the population variance is known. Now that's not very realistic. So thirdly, we're going to go on and try to draw inferences about the population means, mu, where obviously mu is still unknown. But now in a more realistic situation where we confess that we don't know what the population variance is, and we're going to estimate it by the sample variance. So in this first video, I'm going to deal with this initial scenario. We're trying to draw inferences about the characteristics of individuals drawn from a normal population in which both the mean and the variance are known. But before doing that, we need to think about some definitions. And the first definition is that of population. And we can think of the population as being all the individuals that we're interested in. So for example, we might consider the population to be all the females that are registered in the University of Alberta in 2020. But more specifically, what we might be interested in are their heights. So that's the population. Heights of all the females registered 2020 in the University of Alberta. Let's assume we don't have the resources to measure the heights of all those individuals. So what we're going to do is we're going to take a sample, which is a subset of the population. The third idea is that of a parameter, which is a characteristic of the population that we're concerned with. And as I said, right now in this video, we're going to be going over this topic, but in subsequent videos associated with Chapter 2, we're going to go over these two topics. And typically what we're going to see is we're interested in estimating these parameters mu. Now let's go back to our normal distribution. If we go back to our normal distribution, remember our normal distribution can be thought of as a probability density function, and a function is just a meat grinder. So what we put in here is the value of y into our meat grinder, and what comes out is f at y, which is our probability density function. So we've got that here. So here y comes in, and the probability density function comes out. The point is we have parameters. And the parameters that we're interested in are the mean and the variance. And we can also think of the standard deviation, but that's just a trivial square root of the variance. So when we're thinking about normal populations, we're thinking about these two parameters, the mean, or one of these guys, and for the time being, what we're going to think about focusing on is the mean. So, what we're interested in is the parameter, the characteristic of the population. Initially, we're going to be we're interested in mu, so we're not going to measure every individual and calculate mu. What we're going to do is we're going to take a sample. We're going to calculate a sample statistic, which I'm going to represent as y bar, and we're going to use y bar to estimate mu. And I'm just going to go over a couple of formulas. First of all, the formula for the statistic, y bar, the sample mean, is equal to the sum of all the yi, I equals 1 to lowercase, oops, make that a little bit clearer, lowercase n divided by lowercase n, as opposed to the population mean, which we can represent as mu, and that's going to be equal to sum all of yi, I equals 1 to uppercase n divided by uppercase n. Now, I'm pretty sure you all know how to calculate a mean, so that's not really the point here. The point here is the notation. Y bar to represent the sample statistic, which is used to estimate mu, which is the population parameter. Lowercase n here represents the number of individuals in our sample. Uppercase n here represents the total number of individuals in the population. So, we'll stop there for our first video.